Okay. Yeah, we're in.
Hello, everybody. This is Edward speaking from RIGOL Technologies. Today, I will have you a comprehensive introduction to the topics of the laser principles, applications, and test solutions. Before it, I will give you a brief concept of how to converge electrical signals to the optical and drive circuits in the business of engineers in the near futures. Because today's any kind of the lasers applications, just like the optical communications, medicine, or radar or military service are applied by the lasers optical devices to implement the communications or signal converge procedures in this advance. Okay, so I will give you the agendas today. For the first part, I will give you a concept of the laser principles and the market introductions. Yeah, and the second one, I will give you the laser characteristics and applications and how it works by the physical or circuits, equivalent circuits principles for your reference. And the third part, I will go to introduce some corresponding test solutions and give you some good successful cases by the RIGOL product, how to use the RIGOL product to do the laser application test among the current market in the past few years. And finally, we will go through the question and answer sessions and welcome everybody to log inside and type your words in the check-in area, and we can have a further discussion and interactions in the final sections, okay? So the first one, we can see what is a laser? Laser, by this meaning of the words, is the light amplifications by stimulated emission of radiations. Let me see what is lasers, okay? So you can see this one, light. What? So light is an optical, right? So the
Hello.
light, hello? Can you hear me?
Đây, nhắn lại mình nhé.
Yes, Edward.
Đây
We can
số
hear
Zalo
you.
của mình đây. Bạn cứ nhắn cho mình đi, mình sẽ kết bạn.
Please turn off your microphone, okay? Somebody
Em cài
turn.
chặn này. Em nhắn cho anh đi, em nhắn cho anh gửi cho
Hello,
anh.
please turn off
Anh
your
nhận tin nhắn này.
microphone.
Để anh đăng đấy. Ok, ok.
Okay, I will keep it going. Okay, so for the light, it means the optical, sort of from the physical perspective. That means there is a cavity here. If a physical wave from the wave perspective, that means the wave is resonated among the cavity, right? So if the wave, it will reach the half lambda wavelength, that means we will have the resonance phenomena. And the light will be amplifications. Yeah, because we have the constructive interference by the resonant cavity. So the light will be amplified. The second one, we will from the particle perspective. Particle, that means photonics. That is one photon here. Sorry. That is one photon here. And we need to stimulate it high energy level and down to the lower energy level. And one particle collide behind the following particles, and it will be ignite several photons. Yeah, to be emitted of a stimulation. So the optical and the photonics, the number will be increased. That is the light amplifications, okay? So the middle characters that is stimulated light, we use the higher energies drop into lower energies and to stimulate the energies and amplify the total energies, okay? And the emission light means finally we have the emissions light and to have a very powerful and high energy, high coherent beam, yeah, direct to the one directions. So that is the lasers, okay? So the second page, you can see the top one. So the top ones, you can see, we can see this is a particle perspective. What? So the one particle incident to the cavities when to do the stimulated particles and another particle from the lower energies to the higher energies. And finally, from the higher energies drop to the back to the fundamental energies. It will be stimulated and amplified by the photonics collisions by the behind particles. Okay, so finally the light will be amplified. And the key characteristics and features of the laser beam, that is the coherent features. What is a coherent? That means all the particles' wavelengths will be at the same phase, at the same start point, time point, and used by the coherent constructive interference simultaneously at the same time frame. Okay, so for the laser principles of the operations, you can see it is a cavity here, right? And there are two reflected mirrors at the two terminals of the cavities. One is at the left side. We call it as the R1. So it has a coatings film at the mirrors here. And it is 100% total reflections by this terminal. But from the other side, this one, we will have the 0.5% coatings. So partially the lens will be reflected by this mirror and keep the wavelengths to do the constructive interference in the cavity, right? So the other light will be output from the right terminals and exported the coherent amplified light from the left-hand side to the right-hand side. So it is the total principles and operation procedures of the laser pole. Okay. So by the materials, back to the previous slide. So in the cavities, there is another very important key point, that is what is the media inside the cavities? We have the gas, solid material, or semiconductor. The gas is a very traditional lasers. It will be implemented for the higher energies power lasers, just like the weapons. Yeah, you see that some kinds of killing the weapons from the Earth to the space. We always use the gas lasers because the gas lasers have much more power and energies to spontaneously stimulate the opticals because some gas particles energies can be emitted at very large levels from the energy gap. So it will be stimulated more energy powers to do the light stimulated. And the second one is the solid laser. Solid laser is a general purpose for the industrial applications, just like the medicine or inspections and any other kind of applications. And the third one is a semiconductor. Semiconductor lasers is very generous used by today's applications, just like the optical communications for the long haul applications, passive AI data centers, optical servers, communications, like that. For the second one, we use it as a Lidar. Lidar is a radar by the optical signals. Yeah, so it is always use the semiconductor lasers to do some advanced modulated signals with this semiconductor devices, because it is very convenient to do some signals carrier and modulated by this kind of structures. But for the contraries, compared to the gas lasers, it's not easy to do the modulated signals because the linear operation area is very small for the gas lasers. So it is very challenges if you want to modulate the one signals on the gas lasers. It will be destroyed, and the distorted signals after the modulations, and we cannot easily demodulate and get a very clear carrier and the signal envelope signals after all the transmission. Yeah. Okay. For the lasers applications, we can see the previous slide, we see the optical communications here. Yeah. So today is we have long haul, right? Like the overseas fiber communications. For example, just if you want to take a wireless phone call or the internet communications from the Asia Pacific to North America, right? We need to use the long haul fiber materials and communication channels under the Pacific Oceans, right? So this is a very traditional optical communications. For the other examples from today's, that is a metropolitan PON, right? This is called the passive optical network among the metropolitan. Yeah. So in our cities, we always use the PON without the source, the passive optical network, to communicate and transmit the Ethernet data by these PON structures. Yeah. And the third one is today's a very famous application, that is artificial intelligence. Because we need to afford the huge data transmissions by the data centers of the artificial intelligence data. So we need to use the data center switch router, right, to transmit the data. Very tremendous data, because we use the optical transceivers to do the data exchange by the data centers. So it is a very hot applications topics among the current market of the optical communications. Okay, so for the second part, we can see this one is the medical applications. Medical applications. You see the many ladies, yeah, it's like the beautiful, want to do the cosmetics, optimize their face, right? Some particles around the face after the 40 or 50 years old. Yeah. So we need to use the medical lasers to remove some particles at their faces. So we need to use the solid lasers like the ruby lasers. Yeah, it's a very good examples of the solid lasers applied for the medical applications among the current market. Yeah. For the third one is the radar's applications. Radar's applications for the first one is military service. Like the aerospace, if we need to launch a rocket, right, at the Earth to the space, for the priority, the 15 seconds after launch, we also need to use Lidar, laser radars, to tracking the rocket's trajectory after they launched from the Earth to the space, because the laser's coherent length is very consistent. So we can need to use these characteristics of coherent features of the lasers can very precisely estimated the positions of this rocket in the air and the directions, how they can go for the next step. But after the 10 seconds to 30 seconds, we will start it by the phase control antenna systems, phase array antenna. Yeah. So this is the whole precisions for the radar's applications by using the lasers, lidars. Okay. For the final one is the optical inspections, like the Doppler speed inspections. For examples, just like the Germans people, yeah, it's very lucky because there's no speed limited at the Autobahn, right? So you can drive very fast, even over the 300 kilometers per hour. So there's no police to track your speed, right? But for the other countries, they need to use the Doppler's speed inspectors to use the lasers, Doppler's applications to track the speed of the car and to have the advanced punishment if you over the speed. So this is the first example for the lasers applications for the overspeed punishment by the police. Okay. For the second one is optical inspection is for semiconductor. Yeah, you know the wafer. Yeah, for this one is MOCVD. CVD manufacture. That means the wafer will be grossed and roast upside here, right? So the surface roughness need to be precisely controlled. So we need to use the laser's light to inspect the surface roughness by using the optical inspections. So for using the laser's Moray interference optical applications, we need to use the mechanism to do the roughness applications. Okay, so this is 4 examples how to use lasers applications in the current industry. Okay, like optical communication, medical, lidar, and optical inspections. Okay, so next one, we will go to the lasers characteristics and operation applications for detailed. Okay. So the first one is the main characteristics of a laser. Today, I have no time to introduce from the gas, solid to the semiconductor. So today I will use these examples of the semiconductor lasers to drive for the examples to drive these topics to introduce you how to use the current hard market to inspect this one. Okay. Yeah. So for the main characteristics of the semiconductor, for one is the optical, like the 3-5 family or the 2-6 family of the PN junctions semiconductor lasers. So you can see it is have the high directivities here and the coherence here, right? And the narrow wavelength bandwidth. That means I have a very narrow line width at the optical spectrum. And also have the high power efficiency because we need to focus the beam size and the spot size is very small. That means the luminance of the optical energies will condense to one spot. So this is the main characteristics of the lasers. And utilize the air or the fiber as a medias. For the lidars, it is purely use the air to treat it as a medias to communicate the optical signals in the air. But for the fibers, for the fibers, you see, we use the optical characteristics, the total refraction characteristics. It is a light And we have the total reflection in the core area to do the transmission. In the middle is the core, and outside is the cladding, right? The center core, the reflection index is very high, is higher than the cladding. Core is higher than the cladding. So it will be induced the total reflection the phenomena along the fiber. Okay, yes. Yeah, this is a vertical cavity surface emission lasers, for example. You know, the semiconductor lasers, we have two types. The first one is a side emissions one, like the DFB lasers or the traditional semiconductor lasers. This is P, this is N. So let's have the mirrors by the two sides, coating by the two sides, and this has a resonance cavity and exported by the right-hand side. That is the traditional horizontal exported lasers. But currently, we use the vertical cavity. So the laser beam will be exported by the vertical and optical vertically output. Yeah. So we need to use some Brock gratings, coatings at the PN junctions. Yeah. So we can use this mechanism to build up the reflector inside the cavity. Yeah, so it is, but it is almost used to use LAN or some passive optical network or the data centers applications based on the 80, 150 nanometers wavelengths by using these VCSEL lasers. The VCSEL lasers have the lower power dissipations and the circle optical field distributions. That means the spot size is circular more than the horizontal. You need the horizontal size we have it's an elliptical size because it's of the diffraction phenomena of the optical characteristics. Okay? Okay. Okay, so the applications we can see use the passive optical network, lasers reading head. For the traditional compact disc, sometimes we need to listen to the music or to see the DVD movies. We use the disc, compact disc. That means use the reading heads, use the VCSEL, the reading heads to read the reflection, the optical signals, and then demodulate it and recover it as the original electrical signals. Furthermore, and the third one is the industrial mechatronics inspection of equipment. Like the bead and steel manufacturing line, we use the lasers to do the inspections, to inspect how it works better and have a precisely controlled procedures during the manufacture. So the lasers applications is wider than any kind of electronic inspection mechanism. Okay. For the optical communications, you can see we can separate for versatile laser dyes applied for the optical communication industry. For this one, you can see the general one, a laser dye is for the 650 nanometers wavelengths. The way this wavelength is red colors for optical. You mean the traditional, you can see the DVD player. Do you remember? Did you remember? There's a real panels. There is a optical communication use the red lasers applications to do the short range communications by the plastic optical fibers. Yeah. And the second one is the Fabry-Perot lasers and distributed feedback lasers. It is a long wavelength beyond the 1300 nanometers, even up to the 1500 nanometers. It would be applied for the metropolitan communications, even to the long haul applications. Yeah. The third one is indium phosphorus lasers. It will be applied for silicon photonics. It is very hot topics currently because we need to condense and minimize and integrated optical devices and electronic devices in the same IC packages. So it is the basis of the silicon photonics. So how we can use the heterogeneous integrated by the laser die into the silicon manufacture line, we need to use some heterogeneous integration methodologies to combine all the devices into the same packages. So it is the hottest pocket among the market for the next generation's optical communications. That is the silicon photonics. Okay. Lasers, before we need to let the lasers work. That means that we need to use the driving circuit to drive the lasers to put the operating point at a linear range. Yeah. As you know, yeah. For example, this is a driver circuit. Like this one is an IV curve, right? IP curve. We can see this is a phenomenon of the lasers. For the current threshold current, after the threshold current, the lasers photonics number will be increased dramatically, like this slope, right? So we need to control to drive the laser operation point at the center of this point here. That means we can use the electronic signals like this one and to get the modulated optical signal, correspondent signals like this one, operate at a linear operation range. So it is a very important characteristic how to drive the laser diode into the linear operation point. So back to the previous slide, driver circuit is very important because we need to get the correct voltage levels and get the right current levels to drive the laser diode into the working area, right? And also operate it at a linear point. So it is not easy. You need use a general plug, power plug mechanism to direct to drive laser diode to operate. So we need to design the driver circuit like the right-hand side of these pictures. So the driver, we have many customers, dedicated companies to develop and design the laser drivers. How to drive the lasers more efficiently to use a small voltage, small current, but we can get the equivalent result of the lasers. So that is a know-how, how to design the driver circuit in the industry's applications. Okay. So for this one, for the laser drivers, we need to operate the lasers at a linear point, the first one. The second one, for optical communications, we need to convert the electronic signals to the optical signals. That means we need to use the modulated mechanism to let the electronic signals to convert to the optical signals more efficiently and to avoid there's no any distorted signals or wave shape after the modulated. Yeah. So for this slide, we can see how to convert electrical signals into the optical signals. We have the three mechanisms to drive the laser to do the modulated. Sorry. For the first one, we can use a direct modulated. That means we can use the direct laser diode. And when we drive it at the linear point and we change voltage level of the power supply or use the function generators to do the voltage variations at this operation point. So we can use the variations of the electrical signals, and then we can get the variations of the optical signals following by operating the linear point. Okay? Yeah. So we need to use the bias T like this circuit. Yeah, so we need to supply the voltage here and get the direct current from here. Yeah, you know, this is AC signals can couplings by this capacitance, but can avoid the DC levels to back to the chipset and damage the circuit. So we need to use a bias T to do the direct bias and the direct modulation. Okay. For the second one is the electron absorption modulations. Electron absorptions, that means during the semiconductor manufacturers, we need to use the this one. This is a cavity, right? So we need to build up another areas to do some dopings of the particles or the chemicals elements inside the semiconductor silicon or gallium arsenide materials to let the carrier or the electronics can be absorbed some energies. Yeah, so it makes this a high energy or low energy that can make the result of the 1010 modulation devices result. Okay. For the final one is the Mach-Zehnder modulation. Mach-Zehnder modulation is a very high cost and very good performance to modulate the signal. It belongs to the outside modulators, the mechanism, because the laser signal is also driven by the outside, and to use lithium niobate materials to separate the optical path waveguide to the separate two-part paths. You know, the lithium niobate, these materials, when we do use the voltage, bias voltage to apply to these materials, it will be changed reflection index. If we change the reflection index, you know, the phase speed of the electromagnetic wave, an optical wave, equals the optical speed divided by the reflected index, right? That means the phase will be changed. And the phase change, that means one path will be in phase and the other path will be out of phase, right? So it will have the disconstructed phenomena, interference at the end of the combined waveguide path. So it will produce a zero signal. If this is in phase, that means at the combined signal point, we have a constructive light wave signals at output terminal. That means we can generate one. So we can use this outside modulated mechanism to build up the 01010 outside modulated signal by using a lithium niobate Mach-Zehnder modulators mechanism. Okay, this is benefit is it can extremely up to the 100 gigabit per second modulated speed, so it can apply for the currently high speed optical communications, even for the 400 gigabit per second, even up to the terabit per second using the Mach-Zehnder. But its shortage is lithium niobate is very large devices, so it is not easy to condense and integrate to a smaller silicon photonics packages. So if we want to use to the silicon photonics, currently we will use the micro ring resonators replace the lithium niobate materials. Yeah, okay. So this is another topics for silicon photonics. If you have the interested in these topics, we can discuss after the class, and you can email me or WeChat me anytime. Okay. For the next page is corresponding test solutions. How the RIGOLs can provide the test solutions for the Europe or global customers. So you can see this one is a driver circuits, which I mentioned in the previous slide, because we need to offer provided the proper voltage and the current supply to the laser diode to make sure the laser can be operated at the linear point and active regions. So we need to use very versatile design mechanisms to design this driver circuit. So we need to use the oscilloscope like the DHO 5000 series, current new one RIGOL product. So we can use this high resolution signals to monitoring the driver circuit, how we can better perform the power regulations, noise performance, or the power regulations performance by using this high performance 12 bits oscilloscope to inspect the accuracy of this driver circuit. Okay. By the way, we can use a power supply to do some linear power supply to drive the drivers into the some working type, and we have the very low noise, the performance, and don't worry about the noise coupling by the power. So it is a power supply mechanism by these applications. For the third one is the multimeters. Of course, we need to monitoring the voltage and the current states, even the resistors status, right? So this is a major big instrument to apply for the driver circuit applications. Okay. For this one, it's the modulators. Modulators, even though we need to generate the electronic high-speed patterns by using function generators, right? Or the arbitrary waveform generators. For example, like we need to generate the PRBS, pseudo-random binary sequence for the optical communication standard, up to the 7, 9, 7, or to the 31. Yeah. So we can use the arbitrary waveform generators to generate any kind of high-speed advanced patterns to drive the modulators into the optical signals significantly. Okay. Or if you don't need to the high-speed patterns generators, we can also use the general purpose function generators to do the lower speed pattern generation. That's with no problem. Of course, we can use oscilloscope to monitor the test result. Even we can use the DS80,000 series high performance scope, DS70,000 series high performance scope to monitoring the optical result in advance. Okay. So finally, I will give you a successful selling cases for medicine lasers applications. This is a good examples in the Taiwan, Taipei cities, because I'm come from the Taiwan, Taipei. So the original, we have some very good successful stories from Taipei Industry Park, and you see this one, Devon side. It's a medical cosmetics lasers to help the ladies to optimize their faces to remove some particles at the faces. So you see this, this is a big power lasers. So we need to get the impulse power laser here. This is a power laser here. And we're using these Ph.D, the photo detectors, right? Yeah. Before we sending the electrical signal, convert optical signal back to the electrical signals and to monitor the electrical signal at the oscilloscope. Yeah. So we need to use the photo detector prior. Yeah, this is the cosmetic lasers. We need to use the photo detectors prior the oscilloscope and convert the optical signal back to the electrical. There has two key phenomena and tips for you as a reference because it is very high speed. So we need to use the matching circuit to match to the 50 ohms terminal impedance match here. So make sure this electrical terminals is 50 ohms here. And the second one, we make sure the responsivity of these photo detectors is better than laser diode. Okay, for example, if a laser diode have the 100 megahertz responsivities, that means the laser diode at least we need to have the 100 megahertz. But I better suggest all of you to buy the overly spec like this 700 megahertz, because sometimes laser we have the higher modulated, higher harmonic component at the spectrum. So we need to use the higher and faster responsivities photo detector to monitoring the tracking the laser diodes application result. So this is good examples and the good tips for you as a reference. How to well utilize the photo detectors combined with the oscilloscope to have a better test result, and how to help the customer to retrieving optical signal and convert to the electrical signal, and to inspect the laser's pulse simulation result. Okay. For the second one is a test result. We sold one MSO 8204 high performance oscilloscope to the 2 gigahertz. So you can see this is a test result. So all the test result is meet the customer's expectations. These customers originals you like to use Tektronix 70 DPO 7254 phosphorus digital phosphorus oscilloscope, but finally they replaced this one to buy RIGOL's 8204 oscilloscope instead of Tektronix DPO series. So it is a very good practice and successful compare and competitions among the Taiwan's electronic market. So that is why I need to introduce you about these applications. Okay. Okay. Today's topics it end up here, and I have a conclusions because lasers has much more applications among the current market. So I suggest all of you to study more principles and how we can use the lasers to apply for some hot topics like artificial intelligence, switch routers, optical communications for long haul, AI data centers applications, cosmetics, medical cosmetics, or some lidars, right? Or the optical inspections, or some consumer products. We all like some aeroplane. We have many kind of optical inspections and lasers inspections applications among the current market. Okay, so this is today's topic. So I'm sorry about my voice today is modulated. So next time I will demodulate my voice and have a good performance to you. Okay. Yeah. So any questions about today's topics, and welcome to write your suggestions in the chatting area, and we can have a better response to you. Okay. Okay, let me see in a chatting area. Okay. Uh, Chatting area. Okay. Okay. Anybody has questions, you can uh type your questions or any suggestions to the chatting area. Or okay, you can also open your microphone to direct the talk to me. That's no problem. Okay. No questions. Any questions? Okay. If all you guys don't have the questions, today's webinars, I think we will end off here, and welcome to join the next topics after 2 months. So today, RIGOL will generate the bi-monthly webinar topics around worldwide. So we will deliver the most famous and hot topics around the market. So we keep to communicate with you guys to talk about emerging and cutting edge technologies, and also combined with RIGOL's test and measurement equipment, following by these hot topics. Okay. Okay. If all you guys don't have the questions, thank you so much to attend these webinars. See you next time. Bye-bye.